Okay, so welcome back. We've been busy over the last few days doing a few bits and pieces for the next stage in our turbo build for the Insignia. So the unit that you can see in front of you is the GTB 2060 VKLR. Not a bad turbo, commonly used on a great deal of Volkswagen big power builds. Obviously, not that I'm aware of it's ever been used before on the Insignia. Very common on the Vectras and Astras, the Z19 engines. Particularly good for several different reasons. Reason number one, obviously, it's a ball bearing turbo, so you've got the benefit of very good spool. It's obviously got a big compressor wheel, so the 60 compressor wheel is capable of flowing possibly enough air for around maybe a little above the 300 bhp mark. So that's the kind of area that we could aim for. It's possible that we're not going to go quite that far initially, but obviously it does give us a massive degree of headroom should we wish to actually go further at a later date. So the 4-branch manifold, as you can see it, obviously we've had to change the joiner on it. So the original turbo didn't have obviously a V-band, so we've had to cut off the actual part of the hot side so that we could weld a V-band onto it. That in itself is quite a sort of complicated setup because the turbine housing is made out of cast steel. So it is weldable, it's MIG weldable, definitely, which is what we've done several times now. But you have to be careful because it's quite brittle and it can crack. So generally speaking, you use an oxyacetylene torch to heat up the turbine housing. Then we MIG weld it on really quite high power, if the truth be told. And then as soon as the V-band's welded on, then we put it into a bucket of sand so that the actual housing can cool slowly rather than cooling quickly, because that's what introduces cracks into those sorts of problems and issues. The stainless steel 4-branch manifold wasn't such a big issue because obviously stainless steel doesn't crack like that, and it is actually quite strong, quite durable. So obviously we had to cut off the original surface, the original joiner. We've had to machine the pipes so that the collector was at the right angle, and then obviously weld the V-band onto the manifold itself. The manifold, as you can see, has been wrapped as well, because obviously we want to keep under bonnet temperatures down as much as possible. The other thing obviously is that we're going for a much bigger turbo, so spool and boost threshold is an issue. So the heat wrapping will allow the maximum energy in the actual exhaust gases to be retained, hopefully until it arrives at the turbine, which will give us probably a little bit of an improvement in spool over what it would have been if we hadn't have fitted it. And obviously the clear benefit of keeping under bonnet temperatures down so that the oxygen has got a higher content in it. Okay, so here's the vehicle itself. Obviously we're quite some distance into dismantling this. So the front bumper is relatively easy to remove. So you've got some plastic sort of grub screws along the bottom. You've got 2 screws in each wheel arch, and then you've got a set of screws that runs across the top here. Couple of clips either side, so you need to give that a good sort of firm tug when you're taking it off. And then obviously once that's been done, you can pretty much lift the actual front bumper off. I've left a couple of screws in it just so that it doesn't go flying off when someone drives past. And try and get that one off. Luckily I've got some tools here, so just a couple of screws that I put in to make sure that the bumper was still attached. So we'll take those off, and then we should be able to remove the front bumper, and you can see what's been going on behind the bumper itself. So the bumper is fairly easy to take off. It isn't a huge issue. So what's been going on behind the bumper is obviously we've removed the radiator pack. So the radiator pack is a 3-piece item. Right at the front, obviously you've got the air conditioning condenser, which I've removed the air conditioning condenser because basically it looked like it had been attacked by a bunch of moths and there were holes all over it. So the bumper comes right off, nice and easy. And then behind there, obviously, you can see the inner workings of all the areas that we've been messing around with. So as you can see, normally on the insignia, the oil drain goes into the block here. That's easy to overcome. So we've got a 20mm core plug. Pop the 20mm core plug into the block there, and that seals up the oil drain, so we won't get any oil draining out of the block. Where are we going to put the oil drain from the turbo? Good question. We haven't found out yet, so it could possibly be that we actually go into the block there, because there's a plate there, as you can see. Depending on the actual angle and the height that the turbo is going to sit at, because obviously you need a downhill drain from the turbo, it may be that we need to remove the actual sump itself and then tap a drain into there so that the turbo can actually drain into the sump. I'd prefer not to have to do that if possible, because it's a pain and it means I'll have to remove the sump, but it is doable. The air conditioning condenser has been removed, the intercooler has been removed, the radiator, as you can see, has been removed, and that gives us a really nice clean area there to actually work with. The power steering oil cooler is just hanging around here. This is the standard intercooler hoses, well known for being pretty pants, if the truth be told. That's obviously going to be replaced with a custom item, because it has to be. We've had to remove the air conditioning condenser. So the air conditioning condenser normally sits here, and it literally was right in the way of the turbo. So the turbo would go on with our 4-branch manifold, but we would literally have about an inch of space for a pipe to run into it to give it its air feed, which obviously was no good. So quite simply what we've done is we've taken the bracket, which is normally bolted to the block. It's about 6 bolts hold it on. So we've removed that bracket and literally just cut it off. So it's now obviously missing. The bracket that you can see here is what was left, and that had to be retained so that obviously we can keep our power steering pump. This is obviously the power steering pump, and on the insignia, irritatingly, it sits at the front of the engine. So obviously you still need part of that bracket to be retained, otherwise it would have made things really, really simple. But you know, it is what it is. We've had to retain that pump. Now obviously, having removed the air conditioning pump, we've now got the issue that the belt was too long. So we've removed the belt, so we've replaced the belt with a shorter item. Part number off the top of my head, I can't remember, but if anybody wants to know what it is, just give me a shout. I think it's something like 6PK 1620 or something like that. But anybody wants to know, oh, actually, here it is. So 6PK 1820. So there you go. There's the belt that you need to remove your air conditioning pump. Okay, nice and easy. Just slip your belt on, and then you don't have any further problems. Now, obviously, we've got to fit the turbo to this. We're going to have to manufacture and custom build a downpipe of some kind to go into the standard insignia exhaust, which is just there. I'm not expecting or anticipating that being too much of a problem. Of course, the next stage will show us whether or not how the oil feed is going to work. Obviously, the standard insignia oil feed comes from the top, but there is actually a tap just there on this block where you could actually fit the oil feed in the style of the sort of Vectra Astra Z19 block. So we could use that if we wanted to. Irritatingly, on that particular turbo, the oil feed goes in from the bottom as well, which is a bit of a pain, because it would have just been a lot easier to just run a pipe straight from there into the top of the turbo. But it doesn't do it on that particular turbo. I don't know why they've designed it that way. The turbo we're about to fit also has water cooling as well, which is a benefit. The good thing with water cooling is that when you've got a turbo and you especially if you've driven it hard, when you then pull up outside your house and turn the ignition off, with a ball bearing turbo, there isn't the flow of oil through it to actually cool it like there is in a journal bearing turbo. So what tends to happen is the oil that's in the ball bearings, which is very thin and very light, actually gets sort of superheated by the temperature which is held in the core of the turbo, and then obviously it sort of turns into a tarry, horrible, nasty substance and then causes all sorts of problems, as you can imagine. With a water-cooled turbo, even with the ignition off, because of what's called thermo-siphoning, the water continues to be pulled through the turbo even with the ignition off and without the pump running. It goes into the turbo, obviously absorbs the heat from it, goes out through the top of the turbo and back into the cooling system, and it constantly does a loop like that, even with the ignition switched off and the engine not running. So, you know, it helps to cool the turbo down and prevent some of the damage which would otherwise occur. Okay, so what we're going to do now is we're going to do our first test fit of the actual turbo and see what it looks like. Okay, so here's the turbo. As you can see, we've got lots of room at the front here. And just slide it straight in and then bolt it up. Okay, this is just a test fit to sort of see, you know, what it looks like, and you know where the oil feed's going to be and what sort of angle the oil drain's going to need and all that kind of malarkey. And obviously it'll also help us to see where the oxygen feed for the actual turbo is going to be as well. So actually that's not too bad. Sits quite nicely. Bring the camera down so you can have a slightly better look. So there you can see there, fitted quite nicely into the block. So, you know, we've got no sort of routing issues. I think we're going to be, you know, without too many issues really. So you've got your exhaust down at the very bottom there. You know, we're going to have to come out here, obviously go down and then come across to the downpipe, but I don't anticipate that being too much of an issue really. I mean, we've got a fair amount of space in there, so you know we should be able to come out sort of quite some distance really, probably a good sort of, you know, 2 or 3 centimeters before we start to hit the bend, and then it will come down there, run fairly straight, and then come along the front. So that actually looks pretty good. I'm quite pleased with how that looks. I'm just going to set this tripod down inside there a little bit. It's not particularly well positioned. The actual feed into the turbo is obviously here, so we're going to have to kind of come out. The only trouble I can see is that normally we would come out of here and go straight up, but we're going to be quite close to the manifold itself. Now we could potentially sort of come out at an angle like that, you know, that could actually work reasonably well. I mean, this is fairly well sort of wrapped, so I don't anticipate there's going to be huge amounts of sort of temperature coming out of there, which would obviously superheat any air before it goes into the turbo. So, you know, it may be that we can do that, and it may be that the actual air feed from the MAF sensor into the turbo can have some kind of sort of shielding around it to make sure that its temperature remains quite low. The compressor housing, obviously we've got the outlet here, but bear in mind obviously that we can loosen the compressor housing and what's called clock the turbo, so we can actually rotate the housing, so the actual outlet of the turbo will in fact probably come out of here and then come down there and then obviously off into the intercooler, which will give us a nice short run, which is lovely. Obviously that'll help with spool. This nice big hole in the side of the turbo here is one of the water feeds, so you know that's got to have a little sort of plug fitted to it, but you can buy them, believe it or not, online. The oil pressure, the oil drain is going to come out of here. So looking at that angle, the way that I'm looking at it, you know, it isn't actually going to be able to go into that plate there, because obviously the drain needs to kind of come down, miss the turbine housing, and then go into there, and it's just not going to do that. You know, it's gonna actually hit the turbine housing. So it does look like we're going to end up having to go into the sump. We've got that sort of little plate there, which is actually quite nicely positioned. This is obviously the standard insignia sump. So we can probably drill a hole into that and then tap into there for our drain. And it actually sits at quite a nice angle. It's virtually right underneath the turbo drain itself. So that's really good. Now, one of the other things that I actually quite like about the V-bands is that you've got a sort of degree of movement and adjustment. So I can actually rotate the turbo a little bit without too much trouble. So there's a good picture of what it looks like. So I can actually rotate the turbo in that direction, which will help me with obviously the fitting of the downpipe and the fabrication of the downpipe, which is really good. Really helpful. I'm trying to set up this tripod a little bit better, well, I'm afraid it's a bit of a forlorn hope. Okay, so there's the power steering pump right beside it, so you know we can move the compressor housing around to accommodate that. So I'm actually looking at that and thinking that looks pretty good, really. Our oil feed is not too bad, actually. I think we're going to be okay with the oil feed, whether we use the one in the block over here or the one that actually comes from the rocker cover gasket. I could potentially run it down here and then into the bottom, and it just mean it's going to be a longer pipe, but so far so good. I think we're actually moving in the right direction.